Now let us try to classify the lattice. So before classifying the lattice, we will first look at the 7 crystal systems, and then we will look at the 14 Bravais lattices. So first let us look at the 7 crystal systems. The 7 crystal systems are classified on the basis of lattice parameters, that is A, B, C and alpha, beta, gamma. First cubic crystal system. You can see that A is equal to B is equal to C and alpha is equal to beta is equal to gamma is equal to 90 degree. And then you have a tetragonal crystal system. Here A is equal to B is not equal to C. See, C is different and alpha is equal to beta is equal to gamma is equal to 90 degree. And you have this monoclinic crystal system. Here you have equal to B is not equal to C and alpha is equal to gamma is equal to 90 degree but beta is not equal to 90 degree. This is called a monoclinic crystal system. So basically you are taking a unit cell and measuring the lattice parameters, and basis of these lattice parameters we will classify the crystal system. Then you have the orthorhombic crystal system, that is here A is not equal to B is not equal to C but alpha is equal to beta is equal to gamma is equal to 90 degree. Then you have the triclinic crystal system. Here you can see that A is equal to B is equal to C in triclinic system, but alpha is not equal to beta is not equal to gamma, and all these are not equal to 90 degree. Then is hexagonal crystal system in which A is equal to B but is not equal to C. So alpha is equal to beta is equal to 90 degree and gamma is equal 120 degree. And then you have the trigonal crystal system in which A is equal to B is equal to C and alpha is equal to beta, but and alpha, beta, gamma are equal, but these are not equal to 90 degree. You memorize all these things, but you should be able to identify the different crystal systems. So totally we have 7 different crystal systems on the basis of the lattice parameters A, B, C, alpha, beta, gamma. Now let us see what are the different lattices. Okay. For crystal system can have a lattice like this, that is simple cubic lattice. Okay, so these are A, B, C, and you can have a body centered cubic unit. So that means there is an atom in the middle of this cubic crystal. So this is for a cubic crystal system. Okay, this is for a cubic crystal system, and then you can also have the atoms at the faces. Okay, these atoms at the faces. So this is called a face centered cubic unit cell. Okay, you can have another uh, cell. So that is the end centered lattice. So that means there is atoms here, here, here. Along with that, you can have atom at the end. See, you can select any end. So this is called end centered cubic lattice. Okay. Then I have selected the cubic crystal system. So like this, there are 7 crystal systems. For each crystal system, you can have 4 different types of lattices. So let us look at this picture. See, I have crystal systems I have selected here is triclinic, then monoclinic, orthorhombic, tetragonal, trigonal, cubic, and hexagonal. These are the crystal systems. So we are classifying the crystal system based upon these lattice parameters here. So first let us take the cubic crystal system. You can see that A1 is equal to A2 is equal to A3. That is, we have, instead of ABC, we have selected A1, A2, A3. And all angles are 90 degree. So based on this, you can have a simple lattice. Um, then you can have volume centered or body centered lattice, I. Then see, another possibility is the base centered cubic lattice. Okay, so not shown. I'll explain why. And then you have the face centered cubic lattice. You can see that the lattices are at the faces. So for this cubic crystal system, you can see that there are totally three lattices. But this ends base centered or end centered, this can also be called end centered, this is absent. So if you look at orthorhombic, here you can see that a simple primitive unit cell, and then you can have a body centered unit cell, then you have the base centered unit cell, then you can have the face centered. All the different types of lattices are present here. But if you look at the tetragonal here, so these are the lattice parameters, and you can see that you have only simple, that is P lattice and I lattice here. Both C lattice and F lattice are missing. For trigonal, you can see that only the simple P lattice is present. Correct. So for 7 crystal systems, you have 4 different lattices. So 7 into 4, that is 28 lattices. You can expect that. But in reality, if you measure this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Actually, there are all lattices, and these are called Bravais lattices. And why? What are the missing lattices? That is, 14 lattices are missing. See, this to the lack of symmetry, which is outside the scope of this course. Uh, I'm not explaining why these 14 lattices are missing, but actually we are just write this as a statement. There are only 14 Bravais lattices. As shown in this picture, there are only 14 Bravais lattices. Why the 14 are missing is outside the scope of this course, so we are not discussing about that. So now let us look at these end-centered orthorhombic lattice. So I told you we have the simple eye lattice, then body-centered eye lattice, then you have the face-centered lattice, then you have the base-centered orthorhombic lattice. This can be called E lattice or C lattice, end-centered lattice. These are different types of lattices. So we have discussed that for this end-centered lattice is present in orthorhombic crystal system. You can see that here is base-centered or end-centered lattice system. So that's we are discussing here. So you can see that there is a lattice point here at the end. Okay, so that is why this is called an end-centered orthorhombic lattice. For an analogy, you can see that this entire crystal is made up of these unit cell repeated through lattice translation. You can assume this to be imagine this as to be a Legos building. By joining the same Legos block, you can construct the entire crystal. You can see that there are several Legos blocks. Each of these Legos blocks have different parameters, different length like A, B. The lattice parameters will be different. So by joining these different unit cells, you can generate the entire crystal system.